Okay, welcome to chapter 3.1, solving quadratic equations. So chapter 2 was basically introducing us to the parabola with three different forms of the quadratic equation, one being standard form, one being the vertex form, and one being the x-intercept form. Now we're going to use one of those three or maybe some more things to solve equations that are quadratic. So the essential question is, how can you use the graph of a quadratic equation to determine the number of real solutions of the equation? And what you will learn in this chapter is how to solve quadratic equations by graphing, how to solve them by algebraically, and how to solve real life problems using quadratics. So solving quadratic equations by graphing. A quadratic equation in one variable is an equation that can be written in the standard form ax squared plus bx plus c equals 0. So we're just going to set y equal to 0 to solve this. So where a, b, and c are real numbers and a cannot be 0 because, let me explain that. If a were 0, then we would have 0x squared plus bx plus c equals 0. Well, 0 times x squared is just 0, and we'd end up with bx plus c equals 0, and that is not a quadratic. That is a linear equation where b is our slope and c is our y-intercept. So we cannot allow a to be 0. A root of an equation is a solution of that equation. So root, solution, zeros, they all mean the same thing, x-intercepts. You can use various methods to solve quadratic equations. And so let's take a look. Okay, core concept, solving quadratic equations. By graphing, you find the x-intercepts of the related function y equals ax squared plus bx plus c. So in other words, if I had the x-axis and the y-axis here, and we always should label that x and this y, and these would have arrows, but I'm not going to take the time now. The x-intercepts of the related function. So if I had a parabola that, say, opened upward, a was positive, it crossed the x-axis here and here, whatever that x value is would be our solution. So that's how we find the x-intercept by graphing. Where does the parabola cross the x-axis? Using square roots. So we're going to write the equation in the form u squared equals d, where u is an algebraic expression, and solve by taking the square root of each side. Okay, this kind of is leading up to calculus, where they do what's called u substitution for finding derivatives. So everything is leading up to something else in math. We're always building. So u squared equals d, and we take the square root of both sides to find u. So then we're going to factor as well. So write the polynomial equation ax squared plus bx plus c equals 0 in the factored form and solve using the zero product property, which is if you have two things, a times b equal to 0, then a has to equal 0 or b has to equal 0. One of the two or both must be 0 in order to get 0 when you multiply. So let's take a look at example 1. Okay, there's a couple of different ways we can solve quadratic equations by graphing, which is example 1. And we can make a table of x and y values. But if it is in standard form, the -6 is our y-intercept. So we are crossing the y-axis right here. A is positive right here. Ax squared, a is 1 in this case, it's positive. This parabola is opening up. X equals -b over 2a is the x value of the axis of the vertex. It is the axis of symmetry. And b is -1. So I always would suggest when you're doing these to write a equals, b equals, and c equals. And a in this case is 1. B is -1, and C is -6, and that is our y-intercept. So if I take -b, be careful with the negatives, a -1 is 1, and 2 times 1 I'll just show it, is 2. So I get 1 over 2 or 1/2. So that means I have a vertical line at, let me do it in blue, 1/2. X equals 1/2. So this is my axis of symmetry right here. There's my axis of symmetry, x equals 1/2. So I know this parabola is going to do the same thing on both sides, and it's opening up. Okay, so if I choose 1 to substitute into this, so then if we did a table x comma y, I just like to start out practicing, learning that x equals negative b over 2a will give you your vertex. Well, how do you find the point that that lies on? Well, then you can substitute in 1/2 for x. So I could write over here, I'll do 1/2. I'm substituting in 1/2 for x, so it's 1/2 squared minus 1/2 minus 6. 1/2 squared is 1/4 minus 1/2 minus 6. Well, 1/4 minus 1/2 is a negative 1/4. Minus 6 is negative 6 and 1/4. So my vertex is the point 1/2 comma negative 6 and 1/4. And then it repeats on the other side. So if I substitute in 1 squared is 1, minus 1 is 0, minus 6 is negative 6 again. So there, that's right there. And then I can substitute in a 2. 2 squared is 4, minus 2 is 2, minus 6 is negative 4. So at 2, we're at negative 4. And I'm 1.5 away from the axis of symmetry. So I go 1/2 and 1 more, and I can do the negative side there. I'm going to keep going till I find the x-axis intercepts because we're solving. That's how we're doing this. And so we're going to substitute in 3. 3 squared is 9, minus 3 is 6, minus 6 is 0. So there it is. There is our point where it crosses the x-axis. That is the point 3, comma 0. And if I go over 1, 2, and 1/2, I'm at the vertex, or the axis of symmetry. And I go over 1/2, 1, 2 more, then I'd be at negative 2, comma 0. And this is going to continue in that fashion. So this thing curves up, comes up, crosses the x-axis at 3, and continues north. Okay, this one's going to turn and come up, crossing the x-axis at negative 2, and that is going to continue. But we found the solutions to this by graphing it. So the solve each equation by graphing. So our answer is x equals negative 2, comma 3. And I could do that in set notation by writing negative 2, comma 3. Okay, hold the phone. Okay, B. Be careful with this. When you're solving a quadratic equation, it's got to equal 0. So I need to subtract 4x from both sides. Okay, and when you do that, you're going to get negative 2x squared minus 4x minus 2 equals 0. So we have to have it equal to 0 before we do anything. So now I'm going to bring that over here just so I can keep writing. I'll drag this over here. Okay, negative 2x squared minus 4x minus 2. Now, before we do anything else, always check to see if there's something you can factor out. Common term in all three, and in this case, it would be negative 2. Or actually, let me just factor out, yeah, negative 2. So if it's negative 2 times x squared plus 2x plus 1 equals 0. Okay, so now we have a quadratic in here and an a that is out in front, a factor out. And what we're going to do is find the x-intercepts. So x equals negative b over 2a. So in this case, a is 1, b equals 2, and c equals 1. So negative b is negative 2 over 2 times a, which is 2. So that's going to be negative 1. So x equals negative 1 is right here. actually, I don't want to put the dot. That is my axis of symmetry. So let me do blue, and let me do a little thicker this time, and we're at -1. Okay, so there's our axes of symmetry. And I should have arrows on that. And label it x equals -1. So when I substitute -1 into this equation, -1 squared is 1, plus 2 times -1, which is -2. So 1 plus -2 is -1, plus 1 is 0, and 0 times -2 is 0. And so this case, we get the vertex to be -1, comma 0, which is right here. All right. And then if I substitute in a 0, if I go back to this equation here, plug in 0, 0 squared is 0, plus 2 times 0 is 0, plus 1, 0 plus 1 is 1, times -2 is -2, so that would be right here. And then if I substitute in, well, I don't even have to, I go over 1 to the axis of symmetry, then I'm going to go over 1 more because it is symmetric, hence axes of symmetry. And then I'll plug in 1. 1 squared is 1, plus 2 times 1 is 2. 1 plus 2 is 3, plus 1 is 4. 4 times a -2 is -8. So 1, we're way down here off the grid at -8. And we would also go over 1, 2, 1, 2, and we'd be over here at -8 again. So our function is coming down like this. Okay, kind of didn't draw that very well. It should go like that. Okay, and then this one's coming down like so. All right, so my y-intercept is -1. I'm sorry, my y-intercept is -1 right here. And my vertex is the point -1, comma 0. There's only one solution to this problem, so my answer is x equals -1. Okay, so here's example 2, but before I do that, I want to go back. In example 1, I'm starting to do this for my students. If you are my student, I'm assigning 3, 8, and 10, and example 1 pertains to those. So after doing example 1, you should have tried these 3 problems. Then go on to example 2, and here we go. And this one is going to cover numbers 14, 16, and 17 from the homework. So watch this example and then do these 3 problems. So here we go, solving each equation using the square root. What that means is we're going to use u squared equals d. In other words, we want to get a constant on one side and the x squared or whatever variable squared all by itself on the left. Okay, so I'm going to add 31 to both sides. And I'm going to get 4x squared. 31's cancel. And 49 plus 31 is 80. Divide both sides by 4. And I get x squared equals 20. I take the square root of both sides. And I'm going to get, now remember when you do square roots, you should do a factor tree. 2 times 10. And 10 is 2 times 5. And I'm going to show this just one time. So the factorization, the prime factorization of 20 is 2 times 2 times 5. So I can rewrite that as the square root of 2 times 2 times 5. But 2 times 2 is 4, and the square root of 4 is 2. So whenever you have 2 numbers on the tree, it becomes 1 on the outside. In other words, the square root of 4 is 2. And the square root of 5 just has to stay underneath the radical. So 2 square root 5 is equivalent to 20. And by the way, when I take the square root of both sides, I'm going to get x equals, and it's a positive or a negative of that value. Because -2 squared is 4 and 2 squared is 4, it goes for all square roots, positive and negative values. So the answer to, oops, what just happened? I think I hit this thing. So the answer to part A is ±2 square root 5. Okay, part B, again, move the constant to the other side by subtracting 9. minus 9 both sides. That will give me 3x squared. 9 minus 9 is 0. 0 plus a negative 9 is negative 9. Divide both sides by 3. And these cancel, and I get x squared equals negative 3. And when I take the square root of both sides, I get x equals, and I say, uh-oh, I cannot get a negative when I square anything. So I'm going to leave that blank, and I'm going to say no real solution. If you get a negative radical under the radicand is negative, you have no real solutions. We will get into imaginary units later in this course, but at this point, we're just going to say there are no real solutions. Okay, and then finally, we have 2/5 quantity x plus 3 squared equals 5. I want to get this 2/5 over to the other side to get rid of fractions. We multiply by the reciprocal, and what you do to one side, you do to the other. So this is a multiplicative property of equality. 5/2 times 2/5 is 10/10 or 1, leaving x plus 3 quantity squared equals 25 over 2. Now that I have this all together and it's squared, I need to take the square root of both sides, and I'm going to get x plus 3 equals plus or minus the square root of 25 over 2. And then I need to subtract 3 from both sides. And that is going to leave me with x on the left plus or minus the square root of 25 over 2. Make sure that radicand or the radical goes down to the denominator, and then minus 3 after. I can take the square root of 25, so I'm going to simplify this some more. The square, I can rewrite this as plus or minus the square root of 25 over the square root of 2 minus 3. And that simplifies even more to x equals plus or minus 5 over the square root of 2 minus 3. Okay, we're still not done. I'm going to expand this a little bit. We are still not done. I cannot leave a radical in the denominator, and there's something that is called, let me just type it up here, rationalizing the denominator. Okay, we have to rationalize the denominator. In other words, the denominator has to be a rational number and radicals are irrational. In order to get rid of that square root of 2 underneath, we're going to multiply 5 over the square root of 2. And we're going to multiply by that denominator of square root of 2 over the square root of 2. Because anything divided by itself is 1. So this will not change the value of this. So I'm going to, that's going to be that, and then we're going to still have this minus 3 over here. And then we get x equals plus or minus 5 times the square root of 2 is 5 square root 2. And 2 square root of 2 times the square root of 2 is the square root of 4. And the square root of 4 is 2. So now the denominator is rational. So that's called rationalizing the denominator. And then we get minus 3. So the answer to this question, there are 2 of them. 5 square root 2 over 2 minus 3, and 5 square root 2 over 2 plus, or I'm sorry, negative 5 square root 2 over 2 minus 3. Okay, and one last thing, I still probably should clean this up a little bit because we're going to get into something soon. And I want to put this in standard form. So this minus 3 should actually be in front. So it's negative 3 plus or minus the 5 square root 2 over 2. So this is a rational number, and this is an irrational number. So we always want to write it as rational plus or minus irrational. And that's leading up to something else later. All right, core concept here is the zero product property. We've discussed this before in class. The zero product property in words says if the product of 2 expressions is 0, then one or both of those expressions equals 0. So in other words, if A and B are expressions and AB equals 0, then A equals 0 or B equals 0. And I'm going to give you an example. So if we had x minus 3 times x plus 2, and they equaled 0. So if this were A here and this were B here, by definition, A times B equals 0, then A has to equal 0, or B has to equal 0. So when I add 3 to both sides here, I get x equals 3. And when I subtract 2 from both sides here, I get x equals negative 2. So if I plug 3 into this now, so then it would be 3 minus 3 times 3 plus 2. And that has to equal 0. Well, 3 minus 3 is 0. And 3 plus 2 is 5. And 0 times 5 is, in fact, 0. I can also plug in the negative 2 to both. Negative 2 minus 3 times negative 2 plus 2 has to equal 0. Negative 2 minus 3 is negative 5. And negative 2 plus 2 is 0. And lo and behold, negative 5 times 0 is, in fact, 0. So if A is 0 or B is 0, or they're both 0, then the products will be 0. All right, here's example 3, solving a quadratic equation by factoring. So after this example, you should be able to do 27 through 33 odd, and you should pause the video and do them before going on to the next example. So here we go. Here is example 3. Again, we have an equation, x squared minus 4x equals 45, and it says to solve it by factoring. Well, the first thing we want to do is get it equal to 0, so this 45 needs to get moved over to the other side by subtracting, and that will lead us to x squared minus 4x minus 45 equals 0. So step 1, get your equation equal to 0. And then once you do that, if there is no leading term, in other words, A is 1, then there's nothing we can factor out of these. So I'm just going to cut to the chase, and I'm going to draw 2 parentheses, and I'm going to put an x in each. We're going to find our A and our B that would make this equation equal to 0 in the zero product property. Now, a lot of you use this method here where you do a box, okay? And I'm not going to do that here, but if you're more comfortable doing that, that is fine. Here's what I do. I always have my students say, okay, tell me what A is, tell me what B is, and tell me what C is, because if we're using the quadratic formula, or if we're going to find the axis of symmetry or the vertex or anything, we need to know what these values are. So in this case, A is 1, B is negative 4, and C is negative 45. And I have a little saying that I use, and it goes kind of like this. Factors of C that add up to B. Okay, so what I'm going to do is I'm going to do a table here. And I want factors of C over here. And the sum, which will give us B. Okay, the sum equals B. So what are factors of C? Well, what is C? C is negative 45. So factors of C are negative 1 times 45. 2 won't go. It's negative 3 times 1 and 5, 15. 4 will not go. 5 will. Negative 5 times 9. 6 won't go. 7 won't go, 8 won't go. So these are all of our factors, but when you have a negative, either these are negative or the bigger ones are. So I'm going to continue, and it's 1 times negative 45, 3 times negative 15, and 5 times negative 9. These are all the factors of C. Now I'm going to add them. 45 plus a negative 1 is 44. I'm looking for negative 4. 15 minus 3, 12. 9 minus 5, 4. Negative 45 plus 1 is negative 44. Negative 15 plus 3 is negative 12. And negative 9 plus 5 is negative 4. And there is my B. So factors of C that add up to B, and 5 is positive, and 9 is negative. And you can always check this by foiling. X times x is x squared. X times negative 9 is negative 9x. 5 times x is 5x. Negative 9x plus 5x is negative 4x. 5 times a negative 9 is negative 45. So once we get this, we then take our answers and set them both equal to 0. X plus 5 equals 0, or x minus 9 equals 0. And so this case, x equals negative 5, and in this case, x equals 9. Okay, if I did it with a set notation, least to greatest, negative 5, comma, 9 are the solutions to this equation. Okay, this is example here is giving us a value where a is not 1. It says finding the zeros of a quadratic function. After doing example 4, you should be able to do 47, 50, and 52 on your homework. And again, I'm going to show you a different way to do this than the squares. So what I do is, first thing, you always look for a GCF. So I should write that. Step 1, GCF question mark. Step 2, there is no greatest common factor. So what I'm going to do, this is just the way I like to do it. I think it's easier than other ways. I'm going to circle the 2, and I'm going to circle the 12. And I'm going to do this. And I'm going to give you my little saying like I did before, but in this case, it's slightly different. Factors of A first times C. I'm going to use an X. Factors of A times C that add up to B. Okay, so before we did factors of C that add up to B, but if A is not 1, then we're going to do factors of A times C that add up to B. So this is, we're just going to rearrange this equation, and then we're going to just manipulate it until we factor it, and then I'm going to show you how I do it. So anyway, first thing we want to do is set that equal to 0. So f of x will be 0 equals, and I'm going to do this A times C, and I'm going to rewrite this. So the 2 is going to go away, so now it's 1. I'm just going to multiply it out over here and move the 2 to the end. Minus 11x plus 2 times 12 is 24. Okay, now I have an A that equals 1, a B that equals negative 11, and a C that equals 24. And that is my A times C, basically. So actually, I don't want to write that. Let me put the actual A, B, and C so I don't confuse you. A is 2, B is negative 11, C is 12. I want factors of A times C that add up to negative 11. Okay, so now I'm going to say 0 equals, and I'm going to do my X and my X. And I do factors of 24 over here. And that is 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then we start repeating 6 times 4, and so on. So these are all the factors of 24, and then I add them to equal B. And 24 plus 1 is 25, 12 plus 2 is 14, 8 plus 3 is 11, 4 plus 6 is 10, and our magic number is 11, but it's a negative. So we also have negative 1 times negative 24, negative 2 times negative 12, because a negative times a negative is positive. So it wasn't this 11. It will be negative 3 times negative 8 and negative 4 times negative 6. And this would give me 24 again, or 25, I'm sorry. Negative 25, we're adding. Negative 14. Negative 11, and there is what I wanted to circle, not this one. So I'm going to move. Oh, it's all connected. So let's just leave it. How about I do this? Let's get rid of this guy right here. So you got to watch your sign. We're looking for negative 11, not positive. And this is negative 10, which just doesn't matter because once you find it, you can stop. So the magic numbers are negative 3 and negative 8. but we're not done. The answer, we do not set these equal to 0 now. Since I took the 2 to the end, I now have to divide both of those by 2. We multiplied by 2, we need to divide by 2. So I'm going to get 0 equals, and here's the last trick. If you have a fraction that doesn't simplify into an integer, the denominator goes back out in front, and we will practice these. And if you like this format, it gets really easy. And then x minus 8 divided by 2 is x minus 4. So there are my two factors. So my answer would be 2x minus 3 equals 0, or x minus 4 equals 0. So this would be 2x equals 3, x equals 4, divide this by 2, and I get x equals 3 halves, or x equals 4. Put that in set notation, 3 halves, comma, 4. And that is the answer to finding the zeros of a quadratic. So if you want to try it this way, that's fine, or you can do your squares thing. But after seeing this example, if you understood it, you should be able to do 47, 50, and 52. Okay, this is example 5, solving a multi-step problem. So after this example, take a look at homework problem number 57. Okay, so we have a monthly teen magazine, has 48,000 subscribers. So let me get my highlighter. Okay, 48,000 subscribers when it charges $20 per annual subscription. For each dollar increase in price, the magazine loses about 2,000 subscribers. How much should the magazine charge to maximize annual revenue? So we're looking for a maximum. So since we're talking about quadratics and parabolas, then this is going to be a parabola opening down like this, and we are looking for the maximum. Okay, so the first thing we want to do in a word problem is identify the variables and define them. So let x represent the price increase, and let r of x represent the annual revenue. And then once we do that, then we want to come up with a verbal model and write a simple, and then write and simplify a quadratic function. So we have annual revenue in dollars equals number of subscribers, which is people, times subscription price, dollars per person. So what I want to do is call this r of x. And number of subscribers is 48,000 already. We have 48,000 subscribers, but every time we increase the price by $1, we're going to lose 2,000. So if x is 1, it'd be 48,000 minus $2,000 times 1, which is $2,000. And 48,000 minus 2,000 is 46,000. So they drop to 46,000 subscribers if they increase by $1, and so on and so on. So that is our amount, number of subscribers, decreasing by 2,000 per dollar. And subscription price, that'll be times, there's a multiplication here, subscription price dollars. So the subscription price right now is $20, but we're going to add $1 for every dollar we add here. We have to, this would be 1, and this is 1, and this would be 2 if this is 2. So at $22, we'd lose 4,000 subscribers, and at $23, we'd lose 6,000 subscribers, and so on, and so on, and so on. So there's our setup. Okay, so if I look at this first parentheses, I can factor out 2,000 because 2,000's even and 48,000's even. So I can factor out 2,000. So I'm going to end up with r of x equals, I'm going to factor out a negative 2,000. And I'm going to put the x first. I want to put this in standard form. So this is going to be times x, because a negative 2,000 times x is negative 2,000x, and this is going to be minus, because a negative times a negative is positive, and this is going to be 24, because 24 times 2,000 is 48,000, and that's going to be times x plus 20. I'm just putting stuff in standard form here. So there is the simplified equation, and what I want to do is, well, if I use the zero product property now, then I get x equals 24 or x equals negative 20. All right, so these are our zeros. And remember, if we have a parabola, I panned down a little bit so it's gone. So if I had a 0 here and a 0 here, remember that our maximum is going to be on the axis of symmetry. And the axis of symmetry is halfway between our zeros. So I can take the midpoint formula, which is add and divide by 2. So you take 24 plus a negative 20 and divide it by 2. And that is going to equal 4 over 2, which equals 2. Okay, so that tells us that if we increase the cost by $2, this is a $2 increase, that is where our maximum is. So the question said, how much should the magazine charge to maximize annual revenue, and what is the maximum annual revenue? So to maximize, it was $20 per subscription. Now it's $22. So that's the first question. How much should the magazine charge to maximize annual revenue? And they should charge $22 per subscription. So then I want to find R of 22 to determine what my maximum revenue is. And that would equal negative 2,000 times 22 minus 24 times 22 plus 20. So all I'm doing is substituting in 22 for x right here. So R of 22 is going to equal negative 2,000, and 22 minus 24 is negative 2, and 22 plus 20 is 42. Okay, so R of 22 is going to equal, a negative times a negative is positive. 2,000 times 2 is 4,000. 4,000 times 42. 4 times 2 is 8. 4 times 4 is 16. It would be 168,000 subscriptions. Is that right? Or did I multiply this wrong? Let me see. Not 168, 968. Okay, 42 times 2 is 84. 84 and 84 is, well, hang on, let me check. Okay, so when you're doing these, you always should think, and that's what I always say, your last step is, does my answer make sense? And that answer did not make sense because I was way lower than what the original was of 48,000 subscribers. And that does not make sense. I do not want R of 22. I want R of 2. Because our increase in price was $2, not $22. It brought it up to 22, but I want R of 2. So R of 2 is going to be negative 2,000 times 2 minus 24 times 2 plus 20. And when I simplified R of 2, that's going to be negative 2,000 times negative 22 times 22. So R of 2 is going to equal, and let me just grab the calculator there for some fairly large numbers. So what I'm doing is negative 2,000 parentheses negative 22 parentheses 22. And that should give me my answer of 968,000 subscribers. Okay, so at $22, you would increase from 48,000 subscribers to, or revenue. The revenue would increase to $968,000, not subscribers. Your subscribers would have decreased, but paying $22 per subscription, the revenue would be $968,000. Okay. Okay, so before I do this problem, I want to read the paragraph or two that were above. It says, when an object is dropped its height h in feet above the ground after t seconds can be modeled by the function h equals negative 16 t squared plus h sub 0, where h sub 0 is the initial height in feet of the object. The graph of h equals negative 16 t squared plus 200, so h sub 0 is 200, is representing the height of an object dropped from an initial height of 200 feet, and it's shown at the left here. So it shows a guy standing on the top of a building, and it's a 200-foot building, 20-story building, and he's dropping something off the side of the building. The model h equals negative 16 t squared plus h sub 0 assumes that the force of air resistance on the object is negligible. Okay, that's a little bit of physics involved there. We won't worry about that. Also, this model applies only to objects dropped on Earth. For planets with stronger or weaker gravitational force, different models are used. Okay, so here's example 6, modeling a dropped object. For a science competition, students must design a container that prevents an egg from breaking when dropping from a height of 50 feet. Write a function that gives the height h in feet of the container after t seconds. And how long does the container take to hit the ground? Okay, so on this problem, what we need to do is, there's our initial height of 50 feet, okay, drop from a height of 50 feet. So it's going to be, this is A, h equals negative 16 t squared plus 50. Okay, so write a function that gives the height h in feet of the container after t seconds. How long does the container take to hit the ground? So it's going to be h, or h of t, equals negative 16 t squared plus 50. B says, find and interpret h of 1 minus h of 1.5. So what we want to do is we want to find h of 1, and we want to find h of 1.5. So h of 1 is going to equal negative 16 times 1 squared plus 50. So h of 1 is going to equal, 1 squared is 1, negative 16 times 1 is negative 16, 50 minus 16 is 34. And now I want to do h of 1.5. So h of 1.5, remember that's time. So this is 1 second, this is 1.5 seconds, and that is going to equal negative 16 times 1.5 squared plus 50. And h of 1.5 is going to equal negative 16 times 2.25, which is 1.5 squared plus 50. So simplifying this, h of 1.5 equals, so I need to multiply 2.25 times 16. So negative 16 times 2.25, and I'm just going to do the whole thing here, plus 50. And I'm going to get 14. Okay, so what does that mean? It means, well, after 1 second, it's going to drop 34 feet. So if we started at 50, so in our scenario, if this were the building and this is 50 feet, okay, if this was 50 feet and we drop something from here, in the first second, it's going to be at the height of 34. So it's going to drop 16. So we're at 34 feet after 1 second. And then after another half second, we're at a height of 14 feet. We're way down here at 14 feet above ground. So it went from 50 to 14 in 1.5 seconds. So what that means is, in that half second, if we subtract these two, we get 20 feet. So it dropped 16 feet in the first second, and then it dropped 20 feet in a half second after that. So we can determine that this thing is falling at a faster rate as it keeps going. Okay, this brings us to the end of chapter 3.1. Exercises are these numbers down below. Please do those and have a great day.